So here are the four images, the four, let me make it a bit bigger. Uh, I did it, but not on this screen. Okay, so here we go. 1, 2, 3, 4. And here's what people said. Mark, actually, you friends can see it, I think, in a way better than me. And this is what Mark said. He said number 4 is the only one that passes through the origin. Only 3, only 1 that is approaching from negative x and passes through the x-axis. Oh dear, okay. And continues in negative y direction. From negative x, passes through x-axis, continues in negative direction. That is correct. We can, yeah, it's true. Goes, touches the x-axis. This doesn't. Cool. Very good. Okay, now let's see. Karen. Number 2 is different because it's flipped in the opposite direction of the others. Oh, interesting. Everybody see that? In other words, 1, 3, and 4, these are always decreasing. If we look at them, let's look at that terminology. They are always decreasing, 1, 3, and 4, but number 2 is always increasing, which makes it look in a different way. So please, you don't have to follow here. I can read them for you, and then you can just keep looking at them. Number 2 is different because both parts are either completely above the x-axis or completely below the x-axis. Number 2. I'm not sure that's the case because I think number 1 also has that characteristic. Or maybe I'm misinterpreting. Number 4 is different because it's the only one to pass through the origin. Somebody, Mark said that already. 3 different because his horizontal asymptote has the highest value. Oh, look at that. So that's number 3. Number 3, you can see that this graph, there's an asymptote here. Obviously, we don't see it. A horizontal asymptote here, we can assume is the x-axis. So we can assume in 2 and 4, no. But this one is the highest value. Love the way that was worded, Karen. Well done. And number 4 is different because the vertical asymptote is not x equals -2. It is x equal -1. True, but the other ones might have an asymptote of x. Oh, x meaning the vertical one. Oh my, look at that. So these all have a vertical asymptote of -2. And number 4, the asymptote is -1. Excellent eye there. Well done, Karen. Alex told me about number 4. Yes. Madiha told me gets closer to the x-axis in the first quadrant, number 1. Yes, so does number 2, by the way. It just comes from a different directions, and so does, well, number 3 doesn't, but number 2 also gets there. 2 doesn't touch the first quadrant. That is true, and it's kind of elaborating or connecting what Karen has said before. 3, the horizontal asymptote is above the x-axis. It is. Nice. And 4 is the only function that passes through the origin. So a lot of you saw that. Good job. Kirushika gives me a reason for 1 only positive rational function with one asymptote being the x-axis. Oh, now let's talk about that for a moment. When Kirushika, when you say positive function for this one, I guess, well, I'm not sure what you mean by positive. So if you want to kind of tell us now, we will be happy to listen. Because I'm not sure what you mean by positive function.
Oh no, I don't know. I thought it was because number 2, I think I thought it was negative, but then I like submitted it and then I kind of regretted.
That's okay. But what made you, what I'm interested really is understanding what you mean by positive or negative.
The whole like opening up, opening downward kind of thing was in my head.
Oh, I see. Okay.
Rational, it kind of threw me off.
That's okay. No, that's okay. That's okay. So really, a function in and of itself is not positive or negative, right? And when we're looking at polynomials, we were looking at leading coefficients, signs of the leading coefficients. But here we can talk about when the function is positive or when the function is negative. But I'm glad you put that up there, Kirushika, because it's a common misunderstanding sometimes. So I really appreciate it. Yeah, and the other comments that you put kind of overlap with what other people have said. And then this is Suzanne, and he tells us the direction of opening, and this is number two, she said. Oh, I see, she gave us one posting for each one. That's how organized she is. Number two, direction of opening is different, which we explored already. The only one with a positive vertical horizontal asymptote. Yeah, I'm not going to repeat what other people have said. Cool, thank you. You know what? These might be also a good way for me to gather information about what you see and evaluate kind of as an observation or a conversation. So this is there, it's open. You can keep posting stuff. I will be able to see it. And I don't think you can see it just yet. But that in and of itself really is not a major disaster. Good job. Excellent. We did Which One Doesn't Belong. Be prepared for us trying to incorporate more crazy things like this. Next class, we're going to do a three-act math, a virtual three-act math, or close to, which should be a lot of fun. Good. So now let's, I want to just divert your attention if you want to go to the Desmos, our Desmos, the first Desmos for rational functions, because that's where most people are, as you can see. And so let's talk about a couple of ideas here. This student did a very, very good job in their responses. And here's what we're beginning to see, the connection that we have between our basic linear function y equals x to its reciprocal, which is 1 over x. There's two key concepts that I want you to observe. One is the sign of the functions as they go from very, very negative infinity to positive infinity. And take a look at what the sign does. For the linear function, all throughout here, the value of the function is negative. And look at what is the value of the sign, not the value, but the sign of the function of the reciprocal. And then when it gets to 0, what happens to the reciprocal? We already determined that it has an asymptote there. And then the linear becomes positive, and take a look at what happens with the reciprocal, the sign. That's one concept. The second concept, and this is very important because that's where people get confused between the two concepts, okay? So the first one is the sign. And we're kind of seeing that the sign, basically, when this one is positive, the other one is. And when the other one is negative, the other one is. Let's talk about what happens with the function are increasing or decreasing. So our linear function is always increasing. And take a look at our rational function. Here is decreasing. And what about here? It's also always decreasing. So those two concepts are critical for what we're going to be working with. And then, of course, on the next screen, you are playing with different values of the, now we have x plus b. We're not changing the slope, but we're changing the y-intercept. And what is the connection? Let's say when I make b equals 2, what is the connection between the y-intercept and the vertical asymptote or the reciprocal, right? So I imagine that you can see it. And if not, we can kind of move it this way. Take a look, right? The orange line. So there's a connection right there. So there's three ideas that we're looking at. The sign of both functions as x goes from minus infinity to positive infinity. the behavior as of increase and decrease, and then the connection here between the value of b, which is our y-intercept for the linear function, and the vertical asymptote for the reciprocal function. Okay, so we're going to do a very similar exploration to the reciprocal of the linear, but this time we're looking at the reciprocal of a quadratic function, which is a rational function. And so what we're exploring on the first screen is just this idea of, okay, somebody here, I don't know who this student is. If you recognize your work, that's cool. It's nice to put a table if you want. You don't have to connect some of these things. What happens, what is the connection between this quadratic and its reciprocal? And some of these graphs are actually very, very interesting. And I hope that you will kind of discover a few things like we tend to do. So play with them, make sure, remember the two concepts or three concepts that we talked about before, as far as what happens with the sign of both functions, from minus infinity to positive infinity, what happens when one function is increasing to the other one, right? And you will see here later in further screens that we are going to be playing with this now a different parameter, right? With what happens when we move our parabola up or down and what effect that has on the reciprocal function. Okay, this assignment, some of you are asking me where the assignments are. This is back to our page, and you can see here are all the assignments. And of course, they're always in assignments. So you can come here and find them there as well, okay? But I think I put them there in a friendly way for you to access. I'm gonna just, before I close, I'm gonna add one last thing. And this is what I wanna mention to you. And it makes me feel really terrible about this, I'll be honest. But as I mentioned before, because our course in theory is more compressed, we are actually doing double the time that you are doing with a regular course you would be doing in day school, excuse me. And I'm very mindful that there's a lot of pressures on you. So what I'm trying to do is exactly what we were doing in class. We're going to pause about now. I've been working for an hour or so. However, if you only take this time to go into Desmos and do a bit of work and then forget about it, there's a danger that later you're really going to be pressed for time. So basically, what I'm asking you is for you, if it's possible, if you have difficulties, I need you to let me know via remind soon. Because if you don't tell me that you have challenges of some sort, I am believing that you're okay to do the work timely, okay? And I understand there's situations, so please, if there's a situation that you need to, that is making it difficult for you, let me know, and we'll figure something out. But otherwise, please just don't come. I mean, you can do whatever you want, but if you come here, work for these, whatever, 30, 40 minutes, and then don't go back in, later there's going to be a crunch because we're kind of keep going, all right? I put the due dates, if you notice, these reciprocal of quadratics, not until May 1st. So it's very lenient. And also the first one to April 27. But sometimes when we have a deadline that is far out, it's like, oh, I'll do it later, right? So please be mindful of that, okay? And then the last thing, as I mentioned last class, here are the assignments, and it's in our front page. 1, 2, 3, the third announcement. All the assignments that are going to be included for mid-mark with a link, corresponding link. Okay, so